Combustion reactions are a special class of redox reactions. And for purpose of this class, it's a situation in which some material is reacted with oxygen to give the oxide of that material. In this reaction, magnesium reacts with oxygen to form magnesium oxide. If the oxygen doesn't give it away, the word oxide should. When dealing with redox reactions in general and combustion reactions specifically, there are typically 4 types of questions we'll see. And they range from easy to hard. Questions range from as simple as, is the reaction a redox reaction, or what kind of redox reaction, all the way up to how many electrons were actually transferred. The last one is the most difficult because you have to know all of the former to be able to determine it. Okay, let's work through a problem. Actually, let's just use the problem right in front of us. Okay, let's go. Is this reaction a redox reaction? And is it a combustion reaction? Well, I can see it's a combustion because you have elemental oxygen going to an oxide, but let's check the redox for sure. What's a redox? Anytime one electron is transferred from even one material. So we know elements by themselves, magnesium and oxygen, have a charge of 0. These are not the ions, these are the elements. But in the form of a molecule, magnesium oxide, magnesium carries a +2 charge and oxygen a -2. So is this a redox? Well, we can see that magnesium gains a +2 charge from 0. So for it to gain a positive charge, electrons must have been lost. Therefore, it is a redox. But continuing, we can see that oxygen goes from 0 to -2, so it must have gained electrons. Now, what was oxidized and what was lost? Well, to that, remember the acronym OIL-REG. Oxidation is lost and reduction is gain. So magnesium goes from 0 to +2. The only way you can do that is to lose 2 electrons. On the other hand, oxygen goes from 0 to -2. You can only gain a -2 charge by gaining 2 electrons. So magnesium lost electrons, so it was oxidized, and oxygen gained electrons, so it was reduced. Okay, let's try another one. This time in full motion. Is the reaction shown, the reaction of methane with oxygen, a combustion reaction? Well, the first thing we notice is that it does have oxygen, and there is a material with carbon in it that it forms the oxide of. And that's the definition of a combustion reaction. Something reacting with oxygen to form the oxide of that material. Well, for the next question, if it's a combustion, then it must have been a redox. So what was oxidized and what was reduced? Well, to do that, we know we have to know the charge on every element to see if it changes from the reactant side to the product side. How about methane? Well, I know the charge on a hydrogen is +1, so the total plus charge must be +4. It's a charge-neutral compound, so it has to sum to 0. Therefore, the total negative charge must be -4. 1 times what equals -4? -4. That's the charge on the carbon, oxygen. That is a standalone element. It is all by itself, and so it bears a charge of 0, as do all standalone or pure elements. Carbon dioxide. Well, let's see. We know oxygen has a -2. 2 times -2 is -4, so the total positive must be +4. 1 times what equals +4? I'm going to go with 4 plus. Notice right quickly that even though carbon has a 4 magnitude, one is a -4 and one is a +4. Continuing on, you know the last one, water, but we will do that for good measure. You know oxygen has a -2. There's one of them, so the total negative is -2. Total positive must be +2. 2 times what equals 2, I'm going to go with positive 1. And you already knew that. So let's clean this up a bit and figure out what was oxidized and what was reduced. Carbon went from -4 to positive 4. So it must have lost 8 electrons. If it gains in positive charge, it must have lost negative charge. So oxidation is lost. Remember, oxidation is loss, reduction is gain. So we know that carbon was oxidized. So what was oxidized? That's the answer. If that were the question on a test, by the way, you would just stop here. You wouldn't do what I'm going to show you next. But let's pretend it was what was reduced. We would have to continue. How about hydrogen? It goes from positive 1 to positive 1. Oh, nothing happening there, so we can forget hydrogen. How about oxygen? It went from 0 to a -2. So how did it do that? It must have what? Each oxygen must have gained 2 electrons. And we know that reduction is gain. And so we know that oxygen was reduced. So what was the oxidizing agent? Oxidizing agent causes something else to be oxidized, so it itself must have been reduced. So we know then that oxygen was the oxidizing agent. And the reducing agent is the thing that was oxidized, so we know that methane was the reducing agent. And finally, for the hard one, how many electrons were transferred? Was it 8? Or is it 2? Or some other answer? Well, to determine that, of course, we have to know the total number of atoms that gave up electron. Each carbon gave up 8 electrons, but how many did it? Well, we only have 1 carbon on the reactant side, so we have a total number of electrons lost is 8. Therefore, the total that gained must be at least 8. So let's look at what was reducing side of the equation. And we have what? Each oxygen gained 2 electrons. But how many oxygens did that? Each oxygen molecule has 2 oxygens, but I have 2 oxygen molecules for a total of 4. So I have 4 oxygens, each giving 2, and that is a total of gain of 8 electrons. And so everything matches well. 8 electrons were lost, and 8 electrons were gained. The answer, how many electrons were transferred? 8 electrons. And although it was explained earlier, here is a written summary of how exactly it was that you determined that carbon reactant had a positive 4 and carbon on the product side had a -4 charge. Essentially, you make that calculation the same way you did when you were determining the charge on a type 2 metal.